Hello everyone. Previous day we have learned about a theorem that was this. For any two three Boolean variables x1, x2 and x3, of course you have to remember that we are dealing with or litigating with the very Boolean algebra B plus dot and complementation. So here the nonempty set has been formed considering consisting of only two members, 0 the additive identity element and 1 the multiplicative identity element. And in this very two element Boolean algebra, for these three Boolean variables x1, x2 and x3, we have learned this commutative law, that is x1 plus x2 equal to x2 plus x1, x1 into x2 equal to x2 into x1. The associative law for addition and multiplication. For addition, this is x1 plus x2 plus x3. This is equal to x1 plus x2 plus x3. The change of this parenthesis. Similarly, the associative law for multiplication, x1 into x2 into x3. This is equal to x1 into x2 into x3. The distributive law of multiplication over addition and the distributive law of addition over multiplication. The distributive law of multiplication over addition, that is x1 into x2 plus x3, this is equal to x1 into x2 plus x1 into x3, and the distributive law of addition over multiplication, this is x1 plus x2 into x3, this is equal to x1 plus x2 into x1 plus x3. And we have also proved in our previous class the distributive law of multiplication over addition, that was this. We have proved this distributive law of multiplication over addition by constructing this assignment table, and we have shown the equality of these two sides, the left hand side and the right hand side. That means we have proved these. And the idempotent law, that was x1 plus x1 equal to x1, and for multiplication x1 into x1, this is equal to x1. Identity laws for addition and multiplication, 0 being the additive identity element, x plus 0, this is equal to x, x being a Boolean variable, and x into 1, this is equal to x, here x also being a Boolean variable, 1 is the multiplicative identity element. Inverse law for the complement element, x complement of x, x plus x complement, this is equal to 1, and x into x complement, this is equal to the additive identity element 0. The dominance law, x plus 1, this is equal to 1, and x into 0, this is equal to 0. The absorption law, this is x1 plus x1 into x2, this is equal to x1, and x1 into x1 plus x2, this is equal to x1. The De Morgan's law, x1 plus x2 whole complement equal to x1 complement into x2 complement, and x1 into x2 the whole complement, this is equal to x1 complement plus x2 complement. The double complement law, this is x complement whole complement, this is equal to x. We have learned all these laws for any three Boolean variables in a two element Boolean algebra B. We shall consider this similar theorem in case of Boolean expressions alpha, beta and gamma. We all know what are the Boolean expressions and how to write it. Here we have considered three Boolean expressions, alpha, beta and gamma. And the similar theorem which we have learned in our previous classes, in this very present, a few seconds ago I have told you the very theorem we shall consider in these treatise for these three Boolean expressions alpha, beta and gamma. That is number 1, the commutative laws, alpha plus beta, this is equal to beta plus alpha. This is the commutativity of addition binary operation, and alpha into beta, this is equal to beta into alpha. This is the commutativity of this multiplication binary operation, and for this multiplication binary operation. And of course you should be cautioned about that we are dealing with the same two element Boolean algebra B plus dot complementation. This is the two element Boolean algebra, and these two element, from this very two element Boolean algebra we have considered these three Boolean expressions alpha, beta and gamma. Associative law for these three members, alpha plus beta plus gamma, this is equal to alpha plus beta plus gamma, and alpha into beta into gamma, this is equal to alpha into beta into gamma. Alpha plus beta, this is in parenthesis, beta gamma is outside the parenthesis. Here we have taken alpha outside the parenthesis and gamma inside the parenthesis. That means that is we have written alpha plus beta plus gamma, and similarly alpha into beta into gamma, this is equal to alpha into beta into gamma. Here the alpha from the parenthesis we have taken outside the parenthesis, and the outside member gamma we have taken into the very parenthesis sign. This is the associativity for multiplication. Similarly, the distributive law of multiplication over addition, this is alpha into beta plus gamma, this is equal to alpha into beta plus alpha into gamma. And the distributive law for addition over multiplication, this is alpha plus beta into gamma, this is equal to alpha plus beta into alpha plus gamma.